Hey guys, it's Vince. Today I'm coming to you in the shop and I am working on what I would say is probably one of, if not the most difficult cables to build. That is a GX16 6-terminal connector. Okay, so a 6-terminal connector will be using my DS Flexion 20 gauge 5 lead, and why it's using the 5 lead is of course the 6 pin will be allocated to the shield drain. And again, in order to use this connector, you can see here that this cable this is really tight. So first thing we have to do is machine open this casing. Before we do that, I want to just show you guys how close these pins are that are going to be terminated. Okay, so you can see the numbers on there. I believe you can see that on camera. You got 1, 2, 3, 4, 5, and 6 is in the middle. 6th pin will be allocated to the shield drain. So again, there is very little room for doing any type of soldering. And that means, of course, there's very little room for error. So if you're going to tackle a job like this, I highly recommend you work very slowly and methodically, or you will paint yourself in a potential corner, and this can become time consuming and of course costly. So tools required: Dremel tool, flex shaft, and then we have a rotary file end melt. We also have a smaller, and when I say smaller, it's smaller diameter drum sander, and that way we can go in and clean up the connector, which of course has to be machined, as well as the base. Now, if you've never machined a connector before, I'm going to start out by telling you, once again, there's virtually no room for error here. If you go too big, especially when I'm presenting it to a client, we don't want to have excess space in here. We'll get debris in there, and if we go too small, naturally we're putting excess stress on our cable. So these are the things that you deal with when utilizing these type of connectors, and you just have to be prepared for it. It's not a big deal, but it is something that needs to be discussed. The cable will be used to control PWM spindle speed control as well as spindle relay, all on one cable. A lot of guys don't know this can be done. It can easily be done, and once again, the client ordered this as a modification to his system, and now I'm building the cable to support it, and I figured you guys will get to see and hopefully appreciate what this job actually entails. So PPE is very important. I'm going to have a lot of fine particulate here. I've got my goggles, and I also have a mask. It's more like a medical mask, just because the filtration is really high. Again, I will start doing this. I'll actually set the Dremel at 12,000 RPM. I find that's a great cutting speed. Again, a lot of guys use Dremels, they turn the speed all the way up. No, there's no need for that. You don't want to cut too fast, and controlling your RPM, once again, gives you more life on your tools. So pay attention to that. And again, I am using the flex shaft so that I can actually maneuver this. So now I'll get everything set up. Good there, and I'll begin the process. You see I let the cable, or the actual flex shaft, rest on the desk, because that allows me more control. And I move this in one symmetrical format. We do it very slow. First thing I want to do is remove any type of surface that is not symmetrical on where the stress relief is. This area right here usually has ridges. We want to take them out. That'll give the cable more area to rest. Coming out good. Now we're going to start opening up on the top, depth clearance for that cable. Now we don't want to do too much. A little bit at a time. work. The burring tool should be, see where we are. Now I recommend using a small piece of cable, a sacrificial piece, so you can see what progress you're making. You can see right now we're just about inside. Just about in. So we'll keep going. Okay, we're in. Now, where most guys go wrong is they think just because the cable fits that they're good. The thing you have to remember is once this the casing of the cable has the shield in it and everything is pushed back into the cable, I'll show you as I do the assembly, it's going to get wider. So you need it to be a little wider as far as the hole that we open, so that we make sure this cable fits in there nice, and you can see how it actually meets with the stress relief end of the connector. It's exactly what we want. Just going to take off a teeny bit more. We're looking good. Okay, we're just about there now. We'll switch our tools. Let's change our bit to the rotary sander. We're just going to reshape now. Once again, priceless, these tools. When you guys are building your cables, you always want to have the right tools. I cannot emphasize that enough. Notice I'm rounding this edge and that edge right there, and also right here, because we do not want scratches through our cable casing. And that's perfect. And there we go. And you can see now how we fit. Everything there is right on. I'm just going to double check, make sure we're square on top, and make sure this looks as nice and symmetrical as possible. That is looking good. Okay. Switch tools one more time, go back to the file, and we will be done. Just want to touch that top real quick, and we're going. Basically just deburring the edges just to make sure everything here is nice. There's your edge. You can see everything nice and clean. We're looking good. Perfect fit. So we're not too tight on top, which is exactly what we want. Just a couple millimeters, just so you have clearance for that cable to breathe ever so slightly. We're set. This is now done. Now, this is where things get fun. I'm not going to speak over the Dremel. You can see we've got ridges in our stress relief. These should also be opened in best practice, meaning they should be leveled symmetrical. We'll do it very carefully. I'm going to move the garbage because naturally if this slips out of my hand, I don't want it to go in the garbage or I'm searching for it forever. So again, methodical use, very light. If you press too hard, you create too much friction, you're going to burn your hand because guaranteed the heat transfer from this will definitely bother you. So move slow, let the tool do the work, just take your time. Okay. Take this side, rotate it around. Go. Switch over. Finalize with our drum sander if we fit it in there right. We could probably clean it up a little more. Make sure your grip is good. Light. Very little pressure. It's getting hot. We'll just chill for a second. And you can see exactly what we've got there. Okay. Looking good. Switch this side. That's us. Check the edges. Over. Done. You can see we're right on. That's exactly what you want. When that compresses, that'll be perfect. Done. Clean everything up. I'm going to cut the video here and get the cable set up so I can show you guys how I'm going to work with that, and then we'll go from there. Alright guys, so I've already got this basically measured out. Here is my template, and that once again is for the depth of cut from the end to where I'll actually be incising the cable. This is roughly 18.5 millimeters. You can see here I've already put a nice incision in it with a single edge razor blade. I do this very carefully. Once this is done and you do it right, now again this is my DS Flex, you just flex the cable and this should come right off and you're ready. There is the end. Now this I usually save, it just depends on how many builds I'm doing. If I have time, in this case I do, I'll just put that to the side because in the future when I have to do another cable, you would do the same, you'll have that. I also cut a piece of heat shrink, which once again is set to actually match where our conductors are. And you can see it slightly exceeds their length and you're good to go. So for my guys out there that want to know the length, no problem. I'll do that live for you. Just give it a width. Because I really don't, I do this more by eye most of the time, but here we go. I'm talking about 8 millimeter. So again, you've got it. Very simple, no secrets. Lots of practice. Okay, cables here. You can see what we've got. For the guys that are not familiar, just looking at this for the first time, you can see we've got our braid shield, and then inside that, being its double shielded cable, we also have our foil, and that's mylar foil. So I'm going to separate this carefully. Now, when guys work on this cable for the first time, they usually are ham-fisted in the sense that they move too fast, and then they'll say, I can't find a shield ring. Well, if you move slow enough, there's that shield ring right there. Now, many of you are saying, man, you really cut the end of that really long. That's going to fit inside that cable's casing, but it's going to extrude past it because you've already cut this too long, and you'd be correct. What you must realize is I cut this long because we want our shield drain, which is right here, to actually be longer than our leads, and then what I'm going to do is cut the leads down to match the cable. Why did I do that? Because the shield drain has to be longer to be manipulated to get into position where it's in that center pin. We'll cover that as we go through. That's why I said this is a lot of preparatory work. This is not a cable you will simply just move with. You actually you move pretty quick, and you will paint yourself once again in a corner, and you'll probably either have to buy a new cable or keep cutting yours down. I've had clients do that. So take your time. Trimming off excess shield. Again, we do not need our tin braided copper. That's gone on this piece. Once again, we will be terminating this cable. Use my Nipix flush cutters here. I recommend you do the same. You can see I'm just feathering out, just like I do a spindle cable. I feather out the tin braided copper so that we can trim it carefully. Okay. We do this carefully, and then we can trim it, give it a haircut, so to speak. And I'm not putting any pressure. Feathering it out. Done. Okay. Try not to disturb your shield drain other than the area you're working in. And once these hairs become very fine, you'll see that from trimming them, you will be able to push these in very carefully. You can see we got some here. Trim them out. And now we're good. Everything is looking good. Okay. So now once this is set, what we're going to do is take our shield drain. We're going to twine this together. We want this to be one. Fire up our UA 995D plus, 800 degrees Celsius. I actually adjusted my temperature slightly on this. I'll probably go 650. I have my channel 1, channel 2, channel 1, channel 3. Channel 3 is 800, channel 1 is 600. This is a much thinner cable, therefore we are not going to use maximum temperature. There's no reason to. You guys will play with that on your own soldering equipment. Always use a temperature that is going to bond immediately. However, don't cook your materials. I cannot emphasize that enough. Kester 186 RMA flux, only one I'll use, and again, flux is being applied. We're just doing this to keep our shield drain right where it needs to be. I forgot to plug that in, no worries. Bring our fan over. Okay, you can see our drop of flux will come over, just touch, right in. Done. Now just heat and make neat. Done. Perfect. So now this is all one unit, and that's exactly what we want. You can see we've got this all set up, guys. It's just like working on a smaller gauge spindle cable. Now what we're going to do is clean our desk, because my mind gets screwed as soon as my desk does. So, heat gun. All I'm doing is heating the casing. You've seen me do this before. Done. Nylon probe. We're going to feed him back. Now the reason we go within the casing, many of you know this from my spindle cables, is because when you go within the casing, you're making sure that there is no material that could potentially make contact with a terminal, and that would be an understatement to be called bad. So we don't want that, and that's exactly what we're doing, just working the cable back. This cable's cut approximately 11 feet. Client's getting 10 feet. I'm actually surprising him. I'm doing this for him. Because this, I feel, should be included when you do anything with PWM. This way it's plug and play operation, pending of course your VFD supports PWM. And I'm going to say that again carefully. This will only work on a system that not only uses a controller that has PWM integration like a G540 or an SMCU, but your VFD must also support it. So if you're doing a retrofit, and this client particularly is, he's doing it on a Gerber, you want to make sure that your VFD will support PWM, or you're going to have to purchase a new VFD, even if the system is set for it. You can see exactly what we've got there. Now we're clean. Take some of this, a little bit of this. I'm at the bottom end of my cleaner. So come over here, just that's flux remover, guys, just so my guys out there that want to know. Everything I have here I'm using, I'll state it, I always state it, are available in my store. If you don't see it, message me. Okay, now we're looking good. We're on our second shield now, and that's what we'll be looking at, which is our Mylar foil. And again, you want to see where it's attached. You can see up here it's not attached, but as we feed down, you can see, whew, spinning my hand. And you can see right here where it's attached. So what we're going to do is use our flush cutters, come in very carefully, not too deep, and just make an incision. Start cleaning it up. Once we do that, you can see, and you want to incise away. Always pull away from where the leads are so you don't accidentally nick them. Because once again, if you nick them, you accept what you like for yourself. When someone buys something from me, I start over. So not a fun process, and it could be very costly on both ends. So you want to make sure. So you can see right now we feathered it, and you can see how I'm incising this once again away from the conductors. Come in, and now I'll pull with this carefully. If I do it carefully, not too much tension, you can see exactly what we've got. Cut that out, trim, trim, and you see right where we're at, double checking everything, we're looking great. We have this little piece right here. Boom. Now we can see we have our yarn right there. And you see how... Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care. How long, once again, these conductors are in comparison to where we're actually going to have our terminals. And I'll show you how we'll naturally rectify that, but we're doing it for a purpose. It's definitely not by mistake. Okay, looking good. Now, lay our cable down. We'll get this out of the way. Like I said, try to keep your desk as clean as possible. At least for me, it works wonders in what I'm able to do and focus on. Taking pieces of yarn, just folding them back against the casing very carefully, use flush cutters, and we snip. Do it again. Very carefully. Done. And this is why working with this cable or any double shielded cable is time consuming and therefore is costly. Especially when we're doing custom cables. I don't need to tell you guys, a lot of cables are one-offs. And now you can see we have a little longer yarn on the inside. You want to be very careful. I usually cut them on an angle so we don't make an incision. And that's good. Get them as low as possible. I'll pull them this way a little bit. Keep trimming. And we'll see what we can manipulate. Because again, the cleaner you get this, the much easier it is to work with your cable. Just like going to the barber, if you had hair, in my case. Okay. All right, we're starting to look good. So we have our shield drain, we have our conductors. Once again, we have 5. Now, what you guys need to realize is it's totally arbitrary on what lead color you use for whatever pin you use. A lot of guys get convoluted in the sense that they'll look at all these lead colors and they try to stay symmetrical with the lead colors. You do not have to do that, mainly because this cable's arbitrary. It doesn't know what it's connected to. So the best way to do this is pick what leads match what pin and leave it at that. Don't try to fight where you'll have a lead going over another lead like this. We want to keep them symmetrical so you get them nice, flare them out, and then just match them to where your pins are and you're set. The only lead that you're concerned about is your shield drain. So now that we've got this all set, everything here is ready to go, we're now going to prep the cable, making sure that the tin braided copper is removed completely. Now we've got our mylar foil removed completely, and we've got our yarn removed completely. And now we're going to tuck everything into the casing as it should be and get this cable ready for termination. Nylon probe again, coming in and just tuck. That's why I tell you guys, always look at where you are, and that's why you notice this is very dull, so nothing is going to penetrate any of our leads. All we're doing is putting pressure to make sure that all of this material is put beneath the casing of the cable. We want it clean and we want it right, and that's the way it's clean and right. Therefore, there we go. Okay, that's us. Now I roll it a little bit, and you'll notice that when you do this correctly, there's really not much fight in there because everything has been cut so short that it's gone. And you can see right here, we have a little piece of casing that's flared up. We'll just trim that guy. Everything there looks nice. So now what I'll do is I'll reheat this one more time because then we can mold our casing slightly. .450 on the heat gun for those of you that want to know the temperature, and that's 450 degrees Fahrenheit. So you're good. Take this, clean everything, and now we're ready. Now you can see where we're at. We're clean. So now what I'm going to do is I'm going to quickly make a measurement on our connector so that we can see approximately where we should be, and I will cut these terminals back and leave the shield drain as long as required. So everything here is set, and then we're golden. So I'll cut that right here. I'm going to get the desk set up with the Magna-Lock so I can get everything in place, and then we're good. Alright guys, I've got the Omni-Vise here with the Magna-Lock system, and you can see this once again is our insulating heat shrink for the conductors on the connector. Okay? Now what I did was get the measurement, because I've already removed, once again, I've shortened these leads down, and how I came up with that is I put this up against the casing, and you can see I have about, oh, give or take 5-6 millimeters of extra lead left. And why is that extra lead left? Because when I go to terminate this, I'm not going to have these right at the end. I'm going to try to get them as close up to the top as possible. So you can see exactly how I did the measuring. Now you also notice that the shield drain is longer, as I said it would be, so that will allow manipulation to once again hit that center pin, which I'm going to work on first, and that gives me a little extra lead to play with and just snip off, which I'll do right now. Take off a little at a time, because if you remove too much, you're SOL again. So just take a time, and we'll just do this right there. Okay, we're looking good. So just feathering these out, just seeing where I'm at. Okay, that looks good. That looks good. So now what I'll start doing is removing the casing on these using 90-degree flush cutters. These are available in my store. You can see their ends are different. Now we'll come in, begin removing what we have here. Do this very carefully. We don't want to cut our conductors. We just want to cut the casing. And that's us. Right there. See where we are. See how much we have left. We're right on. Okay. Looking good. Once you get one where you need it, the rest of them are pretty easy to follow. I'm just going to come in. Let that come up to temperature. And again, I always like to meet up with the flux actually within the solder itself, because you're always adding a little more flux. The more flux you have, the better off you are. Done? That's one. Now we just keep going. And this is the most time consuming, because you want to do this carefully and everything must be done relatively precise. You don't have a lot of room for error here. If you notice and you pull the casing a little bit, no worries. PVC is very soft. You can always heat it. I've done this in previous videos. I may have to do it, and I'll show it to you how it's done. It's not a big deal. Come in, touch, done. That's fine. If you get a little more solder on, don't worry about it, because once it gets kissed on the conductor, as far as the connectors end, you'll be fine. You notice I'm just feathering down our edges of our conductor. So casing looks great. Now we'll keep going. See if I can get my hand over there. It's about the biggest thing. And this is where that fine-tuning needle nose comes in. I can just manipulate as required the casing, making sure these are all coming in real nice. Just like that. You can see just how nice, how much we're actually coming up. You can see that right there. Perfect. So we're looking good. Bring them back a little bit. Back a little bit. Again, 20 gauge is very easy to work with compared to 16 gauge. It's much thinner. Requires a little more respect because of that, but really when you're doing this, it's very easy. Cool. You just see how fast that flux works. It's just immediate. As soon as you get it, you got it. thinner the cable, it absorbs way more than on a thicker cable. So we're almost there now. We've got the yellow-green stripe lead left. I always recommend staying slightly above. You can always manipulate casing when you're in. That's what I'll do. I'll manipulate it right here. Push. Come in. Get some. We're looking good. A little coinciding. Making sure the leads look good. Everything's looking good there. Now I'll come in and heat. Make sure these conductors are nice and soft. That's imperative to be soft. And you'll see you can then manipulate them whichever way you have to go. Nice. Nice. Okay, now we're looking good. So now, once again, these were the ends of the conductors we don't need. We're going to do our final measuring to make sure everything is looking good, because once again, once we get the ball rolling, that's it. So this looks great right there. Let's just see something. Put that guy in there. And that will have to come out. Okay. Just see something. It's going to go right there. Right in. Perfect. And then we're good. Okay. Looking sporty. Check that out. That looks good. See where we are. Right about in. Right about there. See where we come up. Cool. Okay. See where we are. Done. Now you will notice with this, I am not looking at having this come up to the casing of the cable for one reason, because this has to have form over here on the conductors. This will take shape once it's wrapped around where all these conductors are. So you'll notice that real quick where we're at. Oh yeah, that looks great. Okay. Now, we're going to rotate our connector so we can get that shield drain. And now, we're going to come right in with that. Feather all your conductors out of the way, because we don't want them to be touching that shield drain, because once it gets soldered, it will be very hot. But we're in right there. Right there. That looks great. Good. Let that go. Okay. Move this out. And now you've seen exactly what I said. We went right in. Everything's clean. Okay. This. Okay. do this right, hitting both flux. I'm going to hit it right on top. Try to get a ball of solder right on top. Done. That's what I mean. There's nothing touching that. And you can see that's a perfect bead right there, right on top. So we're good there. We'll rotate and keep going. And that's us. So check and see everything aligns. 1, 2. Okay. Here we go. Everything should be just about lined up. Should not have to go crazy. Now I'll heat each casing to just pull them back a little bit. Go to get a needle nose. Right there. We're on a slight angle here, so I'll manipulate the conductor with the needle nose as much as possible, feathering it in to make sure we get that right where we want it. Got a little bit of dry connection, no worries. That's why you're using low heat, because low heat, you're right in. Turn up the heat slightly. I'll just switch over now. I'm going to go over to the 850. I'll be much quicker. Or excuse me, the 800. And you can see right where we are, and that's exactly what a dry connection will look like. If you look at this, it's still tacked, but it's not saturated. We want saturation. Position is excellent, looks really good. We just want it to be right on. There we go. Now when the temperature's up, of course, you have to be faster. So what I'm going to do is going to balance this so I take some pressure off. Hit this with more flux. That's it. That's how fast. Beautiful. That's one. Let's keep going. I'm gonna go rapid fire motion. We got a cut, or are you good?
I'm at 15.
Okay, kill it. We'll be, guys, continuing on. Blue lead, gonna tin its conductor. You notice my iron's always on a fine angle. Done. If you get a little tail like that, don't worry, that's a byproduct of the heat I'm using. I'm just gonna hit it real quick. I've got to be quicker because the heat is very fast. Done. It's perfect. It's evaporating that flux that quick, and that's why we want to be very, very careful. See if I can get that right where I want her. Like that. It's like I said, you're making adjustments all the time for your heat. You see exactly what we've got. We'll clean these when we get done, but you can see as we're rotating, we got that right there. Everything is in perfect alignment. We'll come in again. And this is why the Omni vise I have trouble keeping in stock because this works awesome for this. You're doing fine type soldering, you want everything to be in a concentric pattern where I can just sit here and rotate as I go. Once again, get that solder right on the tip. Done. It just shows you how fast that Kester evaporates. Check this, give me a nice level piece. 1, 2, 3. Now we'll come in and heat that. So you guys understand then when you get quoted cable pricing, depending on what cable you're doing. I've had guys contact me doing 25, 30 pin cables and they get shell shocked, sticker shock I should say, whenever they get quoted. And it's like, well, I think you need to be aware of what you're asking for. Done. Got a little tail there, we'll fix that real quick. Done. Perfect. There's just no way to cut corners on these. They've got to be done right. Imagine if you had more leads, it's the same principle. Every lead has got to be right on the money. My guys out there that do circuit board work, same principle. You're doing them real fine chips, any type of replacement, any type of rework, and you've got to pay attention. Once again, flawless. These are looking great. Come in, slide it in, and just keep going. Get that out the way. That's why I say if you guys adjust the heat on your gun, or your soldering iron I should say, just pay attention to that duration that you leave the heat on, because that's what's going to play the biggest role. You can go as fast as you want to solder, just remember, the higher the heat, the less time you're going to have to manipulate that component, because that flux will burn right off, and when it does, you're going to be left with a dry connection. So pay close attention to how fast you are soldering. I cannot emphasize that enough. I've had clients contact me and say, I can't get those connections as shiny as yours, and I'm like, well, let's see what they look like. And usually it's that we're evaporating too quick, moving too abruptly. Let's see, I can't see that. Let me see. Looking good. Touch it again. Big thing is your flux. Always your flux. That's how fast. The other thing is when you're dealing with thinner gauge cable like this, you want to make sure, can't tell if that's a conductor. Let me see something. Looks like we have a little tail right there on the conductor is what I was talking about. See if we can correct that guy. Flawless. That's what we want. Last one. Now again, on the Omni vise, you'll notice these rubber jaws, they adjust. And this way, we're golden. We hurt nothing, and everything comes out beautiful. Okay. Heat that guy up. some of you may be asking why I didn't tin this prior to putting the conductors there. That's totally up to you. I kind of like doing it this way because I can see my alignment. It just helps me out a little better with the way the angle of the light is. Everybody's different. As long as it's tin, it ain't gonna matter. Tomato, tomato, and you're in. You are in. Always pitching your conductors slightly. Whoopsie. And we're in. Check it. That looks great. Might just hit one more time there. We have a built cable. At least on this end. And you can see that amount of flux right there. Hoping you guys can see that. That shadow. When you've got that shadow, you're golden. That means you're letting some of that flux still stay there, and that's great because it's still going to keep that joint nice and wet, and you'll see what you're left with. How's it look? I can't see on that angle. Look good? All right, guys, there you go. You can see exactly what we're left with here. Looking pretty. And there we go. Okay, so now we're all set. And you can see our shield drain is in the middle. This is like iron right now. You see that shield drain right there in the center. Right there. So everything immaculately cleaned. That is why I use Kester products. I mean, if there's no definition better than this, and this is one hell of a cable connector to work with, and you've seen why. So now what we're gonna do, close it up. Now what I like to do is heat this because we want to relax our leads. Guys ask me that all the time, why do you heat it after? Basically, you've just given these leads trauma because you've attached everything. So before it was nice and flexible, now it's not so flexible. So we just heat everything, make sure everything relaxes. Now, you can also pull up your casing. And like magic, pretty neat. Because this is much thinner cable, so you can work your casing up and you see exactly what you're left with. And this way, we're not putting stress on anything because we already heated it. I'm just slowly rotating the cable and you work with it. And there we go. So now we'll see what our insulator looks like. And that's exactly what we wanted right there. And you can see we've got a slight gap, and that slight gap in this particular instance is a good thing because you can see how those conductors are all jigged into place once they're soldered on this, and it's a round conductors as far as how they're located, more like a Gatling gun, the way it goes all the way around. So we don't want to put excess stress on these leads. They're much thinner than a spindle cable. So now what I'll do is I'm going to come in here with the precision heat. We'll just hit it on the bottom. Okay. Right here. Now many of you, if you're paying attention, realize I did not record what lead went to what conductor. That's because I still have to do the other end of the cable, and we'll do a continuity check, and that will allocate what conductor color is allocated to what pin. So if you're paying that close attention, which I hope you are, then it'll all make sense. See exactly where we are with this. This looks fantastic. Now we're in. I'm going to move this up a little more. I'll work it slowly. You can see how close you can get that real close, and the cooler the cable gets, It'll retract slightly, but not much, and we're right on the money. This is right on the money. Just working it. Give us a slight gap. Everything is met. Not too much pressure on there, and we're set. There you go. Let's see what we got. Let's see if we have joy. We just slide you up. Now we're going to lock you in. Okay, let's see. Done. There you go. So alignment's perfect. Everything there is good. Clean up here, wherever your conductors, excuse me, your casing is, where it's meeting your stress relief, and you're in. And there's your whole alignment for your GX16 right there, and we're in. That's why I said heating the cable is your best friend. This end will be done. I'm just going to close this up. Lay this here. And then I'll work on the other end. Show you guys how that's done. The other end is much easier. As many of you already know, working on these cables, whenever you're doing the end with conductors that are open, much easier. This one, you're going to earn your money with, and I earn mine every time I work on these. There is no room for error. You saw exactly what we were working with, and if you move too fast, you will paint yourself in a corner. And again, slow is smooth, smooth is fast. Make sure that's in there straight. There we go. Perfect. Never over tighten those either. I've had a lot of different experiences with that. That's why, once again, we want to pay attention to what we're working with. Come in, put our beautiful machined stress relief on. That will apply some Loctite on these. Once they're in, I'll put them on the ends of the screw. Make sure we're in. Done. Okay, stress relief, once again, we do not want to go crazy with our tension. We also want to look at how even we are. I always check screws on the bottom to make sure we have basically even penetration all the way through. So we don't have one side pulling more than the other, or at least not too much. You go by feel on this. Just take your time. And remember, if you're doing it right in terms of what we've got connected with our shield drain on pin 6, I've already got the ground bus allocated in the system. You can sleep easy knowing that everything is grounded properly and you'll have a nice stable system. I tell you guys all the time, it's more than just watching motion on YouTube. We see that on a lot of different videos, but we don't want to just watch motion. We want to make sure that that motion will be stable when it's actually doing what it's meant to do, which is cut. So, good there, good there. This one's a little short. Good. And good. Okay. Awesome. Heat it one more time. Apply the oxide. This end is done. That's it. This, once again, relaxes the casing where it's getting crimped because of the stress relief. Okay. Good. Perfect. There you go. Apply some Loctite in between. Make sure we're good. The Oxide Gold. Every, I would say at least 20 to 30 of Fortune 500 use this. It's a cleaner enhancer to all of your connections. I use it on all of my components. Whenever I build a client system, all his connections are done with this. And you know what? Truthfully, most of them don't even know it. But now you do, because you're paying attention. Okay, everything's good with cleaner end. Okay, good here. This is good. Now we're set. That's all good. Okay. Now Loctite, what I like to do is I'll apply Loctite on a toothpick. Kind of like touch-up paint for a car. Old school style. And that will give me right there. Right there. Should go in there. Sometimes you just don't want a lot coming out. Good. Got that. Clean that off. Less is more. This is the blue Loctite too, just so everybody knows, 242, and not generic. This is the real deal, guys. You want to make sure you're always using the best products, because trust me, you'll screw yourself in the end if you're not. We're done with this. Now I'm going to cut the video and I will prep the opposite end of the cable so that you guys can see the end that gets interfaced with the VFD's terminal block. Alright guys, this is the opposite end of the cable now we're working on, and this will be for integration into the VFD's terminal block. Therefore, we are using 5 ferrules, which will be soldered on as well as crimped. And then of course we have our double wall heat shrink, which will formulate a boot at the end of the cable. I've already prepped it because you already saw me prep the opposite end. There's no point in boring you with that process. You will notice there is no shield drain here. Why is that? Because you're paying attention. You know it's already ground drain on the opposite end of the cable when it's plugged in to the enclosure. So this is all set to go. I've already measured the leads and cut them evenly, so that's all set. All we have to do now is take our Knipex and we're going to strip back the amount of casing required on each lead. And once the insulation has been stripped, we will apply our ferrules, and then at the end of that apply soldering. Now I recommend staying at about 11 millimeters, and the reason I recommend staying at about 11 millimeters, and I'll show you, is because we are left with a beautiful piece of copper from our conductors that we can once again come past the ferrule. And you'll see what I mean. We're sticking out slightly, maybe 2 millimeters, 3 millimeters. Okay? A lot of guys, when they apply ferrules, they cut it really short. They'll have it in the barrel, but you always should have that extruded past the ferrule and then trim the excess off if you're not going to solder. I don't do that. I will trim it off and then I apply solder and flux as well, because I don't trust crimps. So needless to say, I then come in here, we're going to just apply it. Done. That's one. Now I'll leave this to the end, and the main reason I'm going to do that is because I have a tendency to forget which ones I've done and haven't done, and it just is easier in the sense, and when I say forget which one I've done as far as cutting it off, I want to make sure when I'm applying solder I know which ones I'm working on. So we'll cut one off at a time. You're all set here. We'll keep moving. And I highly recommend strippers that will measure, and that's all I use, is the Knipex for that reason, because we want to make sure that every time we do this is measured. You see, bottom it out on the bottom, you're getting the same amount of casing exposed, or excuse me, conductor exposed, and we're in. 2 done. And this is why guys like these, because they're that fast to do. The problem is, and I've said this before, you're hoping that these crimps are done perfectly. And when you apply solder to them as well as the crimp, you're getting the best of both worlds. Now you can obviously do this on all of your connections if you want. If you want to use crimp connectors and do the soldering after, I've had clients ask me that, you can certainly do that. It's just extra work. If you're going to solder, you might as well just do it right the first time and be done. Done. Another one. Now, if you guys need for rules or you need a kit to do connections, I have an entire kit including the crimp tool. So you guys are set and done. So now these are all done. We can see the copper protruding out slightly, and that's exactly what you want. Now what I'm going to do is I'm going to take off the excess copper with flush cutters, and then we will apply a tiny bit of solder and flux on the end to make sure these ain't going nowhere and that we do have full conduction. Take it off. Right here you can see how level. Now what I'll do is I'll take a little bit of flux. If you're not getting any flux out with a little bit of pressure on there, heat it. And now that tip will flow easily. Drop my temperature down to 650. I don't want to cook these conductors. I simply want to add a bit of safety by applying solder and flux. Done. That's one. You see how perfect? That's done. Trim. Right there. Come back up. And this is why I said I leave these, because if I leave them with the ends of copper sticking out, it's much easier to see what you've worked on, what you haven't. Fill the barrel with flux, certainly not going to hurt nothing. Done. Perfect. If you want a shiny finish, just add a little more flux. And usually that shiny finish comes right on the second touch. Done. There you go. That's it. And that's just from the amount of flux you have on there. And we'll clean all these when we're done. Perfect. Just make sure we fill it better. And that's why we lower our heat, because if we lower our heat, we're just getting that right in there, which is exactly what we want. Dead on. Perfect. Okay. Do this guy. Making sure that that's all nice and clean. And do not squeeze the bottle of flux too much, especially in that position, or you will get a ton of it out. Almost got it. Try to use all the flux I have. Dead on. This one. I'm going to tell you something that you might laugh at, but it's not really that funny. Make sure you sweep up your copper from your cables, because if you walk around in your shop barefoot, and I occasionally do, it will get in your foot and you will be cursing. So just be careful. So, when they're all done, you can see that beautiful shiny. Right on the tips, everything is set. Those are good. So right now, we're all set with these. We'll clean them up. Just make sure everything is nice. Now these will have deoxit applied to them so that they're protected just like the other end. Cool. All set there. Kill that. Now you can see our boot. And a boot is just that. It is a boot. So we'll line everything up. You can see exactly what we got. Now this is arbitrary. You can put these in any order really you want. I mean, it's not, once again, there's no real particular order required, because this is just going to be an interface cable between the VFD and, of course, the controller. The only thing that's going to matter is what pin allocation goes where, but other than that, you're set. So now we've got our boot set up, and I usually leave this end opened, but we will come in just slightly, and that is a very nice boot. Now what we're going to do, leave this up. I'll take and add precision heat underneath. We'll get a nice bead going. Get this sealed, so to speak. And we're in. Watch how it creeps. Again, that's why I use low heat for this. Whenever I'm doing precision work and I want to control where I'm heating, how much heat something is getting, you guys will love having a soldering station for that reason. A good soldering station with good heat control allows you to do some miraculous type work. Now you heard that gun speed up a little bit. It's because it's naturally trying to cool off. Now I used it right away again, but that's not a problem. And once you get past the edge that you formed, you notice I'm just casually working it down. And once I get past the edge and I have clearance, I can switch over to the large gun. I just don't want to affect how I made that boot, and everything is set there. So we'll come in here. I'm going to rotisserie it. There we go. That's it. There you go. So we've got our double wall heat shrink with adhesive. It's bonded. Everything there is set. This is set. And now all he's got to do, we'll apply some deoxit to these, and we're going to check it with our multimeter to check continuity, and then we can allocate what number is allocated to each lead, and then we're set. Cable is supplied with the controller, and he is once again good to go. I hope that this video has been helpful, guys. These videos right here, to the guys that are serious, I feel are priceless, because I don't know of anyone doing this. No one's showing you this, and they're certainly not showing you using the correct double shielded cable and going over how to allocate shield drains, what tools to use, what solder to use, the proper technique. This all plays a huge role, and you guys be the judge. You see the finished product. So again, the client's set to go. He'll have his Gerber up and running in no time, and we'll be good. Thank you all for your support. Take care.